Welcome back. In this video we're going to be restoring the TSB 1 and the TSB 2 initial aftertouch multiplexer boards. The function of the circuitry on the TSB 1 and TSB 2 is to select the analog pressure voltages from the depressed keys, then buffer the signals and route them into the TKC board. Each TSB board decodes 1/2 of the entire keyboard. Both boards are virtually identical. The TSB 1 and 2 generate a short initial trigger voltage followed by the actual sampled pressure voltage of each key. Each key on the keyboard has a switch. When the key is not pressed, 8.5 volts keeps a small 0.33 microfarad tantalum capacitor fully charged. When the key is depressed, the capacitor is discharged into an input of a given 4051 analog multiplexer IC. This short discharge pulse is immediately followed by the voltage from the key pressure sensor. A 1 microfarad electrolytic, 0.047 microfarad mylar, and several resistors comprise a signal filter network. Each key has its own dedicated filter network. It means that there are 61 banks of little capacitors and resistors. The 4051s decode the proper inputs and hence the proper pressed key as instructed by a 3-bit instruction code generated by the TKC logic here. The multiplexed aftertouch voltages exiting the TSB 1 and 2 boards enter the TKC board for further decoding. Like the TKC board, the ICs, the 4051s, are susceptible to age-related failures, so these will all be replaced. I am also going to be replacing the tantalum capacitors with polystyrene and also these mylar with polypropylene. The electrolytics will all be replaced with brand new Panasonic EB series. This is just to ensure long-term reliability of a very critical part of the keyboard's functionality. Once the analog voltages have been multiplexed by the 4051s, they enter into a buffer stage, which is formed by these dual op amps. There are 3 of these chips on each TSB board, and that gives you a total of 6 channels, although 1 channel is not used. So there are 5 analog channels that come out of each of these TSB boards that then go into the TKC for processing. Keys with initial touch trigger problems or variations in key aftertouch performance may be contributed to the TSB 1 and TSB 2. It is therefore recommended to replace all age-affected components with new to ensure long-term reliability. We'll begin service on the TSB 2 board since it's easier to access. The board is held in place with 4 wood screws and spacers. Remove the 4 screws. The first components that we're going to be replacing will be the electrolytic capacitors, these little black cylinders. I'm going to go ahead and start by unsoldering all these electrolytics on both sides. All the electrolytics are removed. You can see the circular silkscreen pattern that represents where each capacitor is supposed to be. So this guy goes into the long lead, goes into the hole closest to the plus, just like that. So your negative marking on your capacitor will be facing towards the chips. Go ahead and install all the electrolytics, and then we'll solder them after that. Okay, with all my capacitors installed and looking pretty, go ahead and flip it over and solder. Here you see all the new electrolytics in place. Next part we're going to get to is the blue tantalum. Look like little blue balloons there. Those are going to go, and then we're going to replace those with some high-end polystyrene. And these tantalums are polarized, but the polystyrene are not. On the top is the original tantalum capacitor. On the bottom is the new polystyrene capacitor. The original tantalums are polarity sensitive, but the styrene are not. Okay, here's a board with the polystyrene caps installed. Next are going to be the .047, which are these big yellow ones right here. So we're going to remove those now, and I'll show you the replacement substitute. Okay, here we have all the old capacitors removed, the mylar ones. And on the top, the yellow capacitor is the mylar. At the bottom is the new replacement, which is a polypropylene. It's a much more stable capacitor, and replacing these throughout the keyboard should increase stability significantly. Here all the .047 microfarads are installed in red. They are non-polarized, so it doesn't matter what direction they go in. So now we're down to the last remaining capacitors. We have a 0.1 right there. And we've got a couple, 1, 2, 3, 4.01s right here. And we've got a few more, or a couple more down at this end here. So I'm going to go ahead and desolder those and remove them. Here we have the replacement capacitors at the top. Again, they are two polypropylene units. The one on the left, 0.01 microfarad. The one on the right is 0.1 microfarad. And it's replacing the two at the bottom, which are the older polystyrene type. Okay, here we have the new capacitors installed. The 0.1 microfarad, the 4.01 microfarads, and now we're going to remove those 4558 dual op amps next. And then over here, this single dual op amp, that's going to be removed. And there's the two new capacitors, the 0.01s, up next to it there. We're going to remove the 4558s, and we're going to install a new version of it, of that chip, as well as sockets. Okay, at the top we have the old JRC 4558, which was removed from the board. Down below it is the new Texas Instruments 4558, and at the bottom is the machine pin socket. Just as with the TKC board earlier, there is a silkscreen marking on the board that indicates pin 1 orientation. There's a notch on the package of the, actually I'm sorry, there's a notch on the actual socket that corresponds with the actual diagram of the notch on the PC board. So these sockets simply insert into the board in the 3 locations and solder them in. Okay, go ahead and insert the dual op amps into their sockets. Be sure to observe the polarity for the pin 1. And the one little guy by himself actually is opposite of the other two. Now remove the 4051 analog multiplexers, and we'll install their sockets next. The last component to install, at the top is the removed 4051, and below it is the brand new part, and below that is the socket, which has a decoupling capacitor. And here you see the completed TSB 2 board screwed back down onto the plywood base. Let's have a close-up here of everything. Here we have the completed polyphonic aftertouch system, the TSB 1 and 2 boards.